Now in example 2, what we've done is we have something very similar to example 1, but what's happening, instead of just having the base with our variable, we've subtracted something within the exponent and we've added something outside of that exponent. This number that's outside that we are adding, oops, let's make that a little bit smaller. So this plus 1 that we have here, that's going to indicate where our asymptote is, because that's telling us that we have kind of shifted our graph up 1. And we'll spend some more time on kind of how shifts are made, but with our exponential growth functions and decay functions, if we are adding or subtracting something outside of that function, that's going to indicate to us where that asymptote is. So if we have this plus 1, what used to be here at y equals 0, we have now moved up to y equals 1. So we're actually going to start here with that asymptote. And we're going to fill in the asymptote as y is equal to 1. Once I have my asymptote, I'm going to go ahead and plot that on my graph, remembering that it is a dotted line, and it is at y equals 1. Next, what I'm going to do is I'm going to fill in the table below. So I'm going to go ahead and put that in my graphing calculator and take a look at that table. And I want you to do the same thing. So let's go ahead and plug it into the graphing calculator. If you've plugged it into your graphing calculator, this is what it should look like. You have 4 raised to the x minus 2, and then make sure you get out of the exponent before you add that 1. So then what we're going to take a look at is our table of values. So we're going to go to our table, and as we scroll through our table, maybe we'll go down and see if we can find some nice numbers real quick. So 417 is a great number, but it's not going to fit in my graph. I go from negative 10 to positive 10. So even though it's a good point to have in my table, it really isn't going to help me graph my function because it's going to be way off the chart. So 3, 5 looks like the best point to start with. So I'm going to start by putting in the ordered pair 3, 5. And then as I scroll through, if I go up a little bit more, I have the point 2, 2, which is another point that will fit on my graph. So I'm going to use the point 2, 2. And as I continue to go up, I have the point 1 and 1.25, which will work. And then I need another point, so as I continue to go up, I have the point 0 and 1.0625. One thing I want you to be aware of, and what I want you to look at on the calculator, is if I continue to go up on my calculator, you see that I eventually get to this point, which is all 1. So I have negative 6, 1, negative 7, 1, negative 8, 1. And what's happening is the numbers are getting so small. If you look at negative 5, it's 1.0001. And the calculator just doesn't have enough place values to give all those decimals that are coming after negative 5. So what it's doing is the calculator is rounding it to the nearest whole number, which is 1. But you have to understand that our graph of our function is not going to be at 1. That's where our asymptote is. So it's approaching 1. It's getting very, very, very close to it, but it will never equal 1. So if you put these types of points into your table, it will be marked wrong. Negative 6, 1 is not an actual point that's on our graph, and you have to understand what the calculator is telling you as you look at that table. So just be aware of that as you work further through this. Now once I have my table of values, I can go ahead and plot it on my graph. So I have the point 3, 5, so I'll plot that point. And then I have the point 2, 2. The point 1 and then 1.25, so I'm pretty close to that asymptote. And then 0, I'm pretty close as well, a little bit farther down. It's just an approximation as you start plotting these points. And then know that your graph is going to go and curve up and to the right, and then it's going to get as close as you can to that asymptote without going over. So do your best. Again, this part's going to be a little bit difficult. Just make sure you're not crossing over that asymptote. Show me that it's getting close but not going over, and again curve and make sure you're going up on a diagonal and not straight up and down. Next I want to know what's the domain of that function. So our domain again is all our x values. Since this graph is going to continue to go to the left and it's going to continue to go up and to the right, we are taking care of every single x value that we need. So we could say the domain of our function is all real numbers. The range of our function, like before, it's going to go hand in hand with that asymptote. So if our asymptote is at 1, we're looking at our graph as either all above 1 or it's going to be all below 1. And since right now we're above the 1, we know all our y values, our range is going to be y is greater than 1. So this number here your asymptote and your range are all going to follow along with that same number. That's where we're getting everything from, is that number right there. If you have questions, let me know. Otherwise, I'd like you to take a second, pause it, do the try this, and then unpause it when you're ready to check your answer. If you did the try this correctly, here are some possibilities you could have for your table. Remember, these are not the only numbers that you could have, but these are some of the nicer ones that you can use to plot on your graph. If we look here, the asymptote is going to be at y equals -5. So we are down here with a dotted line. And we can fill that in for part B, y is equal to -5. Plotting our points, we have -2, 4, -3, -2, -4, -4, and then -5, -4.67. So our graph is going to come up and then right along our asymptote here. The domain of our function is all real numbers, and the range y is greater than -5. Questions? Let me know.